Automatic orders will be placed. All of that can be fully automated using database technology. In a web environment, databases can also be successfully adopted. Databases can be used to store HTML, hypertext markup language information. HTML is a standard which is going to focus on the representation of web documents. Or information into PDF documents. You can have a PDF document that actually has a product description or any kind of product information, and that you also wish to store in your database application. It could also be used to store images, XML-based documents, and so on. In a supermarket setting, you can sometimes have really huge databases. Think about Walmart. Walmart is probably the biggest supermarket in the world. It's an American supermarket. And it's going to store information about all the products that it sells together with all the transactions themselves. Walmart recently decided to also invest into RFID technology, which stands for radio frequency identification. That means that all the Walmart products, instead of barcodes, will be equipped with small antennas. Small antennas that will allow the products to communicate with the database application by means of transceivers built into the roof of the supermarket. That means the database application can continuously monitor where the products are, in what quantities there are, what products tend to pass their expiry date, etc. So this generates a tremendous amount of data, and given the size of it, one typically no longer speaks about databases, but about data warehouses. So data warehouses are typically very large-scale, huge databases with different terabytes or even more of data being collected, sometimes even on a daily basis. Let's look at some definitions now. So a database is a collection of interrelated data. What do we mean with interrelated data? Well, this is data with relationships between the various concepts underlying the data. Think about a university application, for example. So in a university application, you can have different information concepts, like you have an information concept of student, you have a concept of a professor, a course, and a building. Now, between those information concepts, you have relationships that exist. A student can take courses, a course can be followed by students. A professor teaches courses, a course is taught by one or more professors. A course takes place in a building. In a building, multiple courses can take place. So you have the data items, the concepts or the objects themselves, student, professor, course, building, and then you have the relationships between them. Well, a database is going to collect both. And it's going to represent some aspects or a subset of the real world, the universe of this course. The universe of this course is the problem setting in which we are working. That could be the university administration, for example. You want to build a system for a university administration. A database is logically coherent. That means all the information items are connected. Students, courses, professors, etc. And it has some inherent meaning. It is meaningful in a particular setting. It also has an intended group of users and applications. So you're going to have different users. You're going to have users like students, which are going to make use of the university administration system just to see what courses they can take or just to register for certain courses, for example. You can have professors that are going to use the university database just to find out what students are subscribed to their courses, how many students, etc. You can have educational program assistants that are going to help students configuring their ISP, individual study program, etc. So you have different types of users and applications. And of course, a database should be appropriately managed. And the way it can be managed is by means of a database management system, or DBMS. And that's a collection of programs, software in other words, that will enable us to create and maintain a database. It will allow us to define, maintain, and monitor a database. So it's like a general purpose software system that is going to facilitate the process of defining databases, but also constructing and manipulating databases. When we say manipulating databases, we mean that it will allow us to insert new information into the database, register new students, for example. It will also allow us to update information into the database, update the marks of a student, for example, or it will also allow us to remove information from the database, for example, removing a course which is no longer offered. So that's a DBMS. It's a collection of software programs that will allow us to do that. A database system is then the combination of both. So it's the combination of the database together with the DBMS, the database management system, software or system. Let's take a step back in time and let's see how approaches towards managing, storing data historically developed. Well, the first approach towards dealing, storing, and managing data is the file-based approach. And that was an approach that was very common in the 60s to 70s of the previous century. Here you can see an example. So imagine we have a couple of departments in a company setting, each with their own application. So we have an invoicing application, we have a CRM application. CRM stands for Customer Relationship Management. It's an application that allows you to manage the customer relationships, understand the needs of the customers, understand interests of the customers, etc. And we have a GIS application. GIS stands for Geographical Information System. A very simple example of a GIS application could be an application that is simply going to figure out where most of your customers live, for example, or where they make their purchases, right? Very, very important information to know. Each of them need data. Of course they do. And the data is being stored into separate files. So you can see 3 separate files here, each storing the data needed for that one particular application. Very important to note is that those files are clearly not integrated. They're separate. And if you have a closer look at some of these files, you see a lot of replication. So you see customer number being recorded here, 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 similar to customer name. Of course, each of these files also contains specific information for the application. So here you're going to have VAT code, you're going to have turnover, and zip code, for example. But what is really worrying is the replication or the duplicate data, because that could create all kinds of issues. Duplicate data can very easily lead up to inconsistencies. Imagine that you would change the customer number here. Imagine that your customer base grows substantially and that you want to change the customer number such that it has more digits now because you have more customers. That would mean, in order to make the connection to the other files, that you would have to change it here, you would have to change it there, and then also change the definitions in each of the applications. So it's going to involve a lot of changes that may easily be forgotten. And if they are forgotten, they have very dramatic impact because it means you have bad data of bad quality, which is no longer well integrated. So you see, this file-based approach to data management has a lot of disadvantages that come with it. It has a lot of problems. Let's zoom into some of the problems into a little bit more detail. Well, the first problem relates to accessing the data. If you want to access specific data elements, that means querying your database or your data, then in a file-based approach, you have to manually program your queries. Here you can see a query, find person, which is going to take the name of a customer as input. And basically, you have to program a small do loop, which is going to actually iterate through each of the lines of the file just to find that one particular person that you're looking for. This is in the file-based approach. So if you have a query, if you want to find particular information, then you have to program it. And of course, it becomes a lot more difficult if you would need information which is stored in different files, because then in your program, you would have to store or you would have to access those different files, bring the data into some kind of staging area, aggregate it, and then make sure that you report the result of the query as desired. So it becomes a very cumbersome exercise to query multiple files simultaneously. This is totally opposed to the database approach. In the database approach, everything will be stored in a database, and the DBMS will foresee DBMS languages to query, manipulate the database. And one of these languages is SQL. SQL stands for Structured Query Language, and just analyze the abbreviation. It's a query language which is structured, so it has certain kind of built-in structure that allows you to formulate your queries in a very user-friendly and effective way. Here you can see an example of a query. Select from the people database where the name is, the particular input name you're looking for. This is a very transparent, efficient way of working with databases. It basically only declares what you need. You no longer have to manually program your query, which was the case in the file-based approach, but you just declare what you want. SQL, as such, is declarative. You declare what you want, and the system will work it out for you, which is really nice, which is really very user-friendly. The file-based approach contains a lot of storage waste, lots of wasted storage space because of duplicates, redundant data. So you have customer number, customer name, remember the previous example, which is being stored in different places. So if you're going to have lots of customers, that will involve lots of duplication of customer numbers and customer names, which is not very nice. So also, if you're going to change your customer data in one file, you will need to change it in all the other files, and you will also need to change the definitions in each of the programs, which is again not very nice. We also have a very strong dependency between applications and data. As I said, the change in the data definition necessitates